So let's get started with the solution of this exercise. Now, there are different ways to go about this, but one of the things that we should first notice is the fact that we have established that x is equal to 0, so the total loss is 0 if and only if there are 0 claims. And this means that the probability that the total loss is equal to 0 is exactly the probability that there are no claims, which is exactly equal to 1 minus p. Now, this was one of the things that we kind of got lost a little bit on during the exercise session, partly due to it being quite late in the afternoon and me being a bit confused. But this is one of the main points when we consider these compound distributions, is that often they act in ways that are not exactly as you are used to, because up until now you have been used to two different types of distributions, right? You had a box for the continuous distributions and you had a box for the discrete distributions. And what we always learned was that for the discrete distributions, you have stuff like probability that n is equal to n, and for the continuous ones, you always had stuff like the density of x and so on. However, there exist stochastic variables that are somewhere around the middle here. There exist stochastic variables that are both continuous for certain values of outcomes, for certain intervals, and discrete for certain other values. And this is the case for x in this exercise. So often compound distributions act this way because of the fact that if we want to look at the probability that x is 0, well, then that is equivalent to the probability that n is 0 and n is discrete. However, if we want to look at the probability that x lies somewhere in an interval that lies above 0, then we look at it in terms of the sums of the y's, and the y's are continuous, which means that we will have to come up with two different cases for x. And that also means that x is not a continuous stochastic variable. It is not just discrete either. It is a combination of those two. So this was just a quick explanation of the motivation behind why x is neither here nor there when it comes to continuity and discreteness. And in the next video, we will try to find the density for x for the values that are greater than 0, where x is established to be continuous.